Alrighty, so yeah, they changed their problem up, so we'll start over. So we're looking at this graph here, and since we've already done it, I'll see what y'all say on this. For this graph, they want us to find f of -2. So what y value has an x value of -2? All right, y'all, so I'm gonna slide the -2 on my x-axis. I'm gonna go straight up and find that point. And it looks like that point is sitting at 3
Yeah.
on the y-axis. So we'll put a 3 in there and then check that answer. So remember, the domain is all my x's here. And y'all, they're going by 1 again. So I'm just going to see this left one is starting here. That looks like a -5.
Yeah.
And then we got 7 points and they're going by 1. So -4, -3, -2, -1. We got a 0. And looks like a 1 for that last one. All right, so we check that answer. So now we want any x values for which f of x equals 5. So what x values have a y value of 5? So y'all, I'm going to climb up, go to 5 on the y-axis, and anything on that horizontal line will have a y value of 5. So I'm going to go to the left side. Looks like the second point has a y value of 5.
Yeah.
And let's see, my chat's saying -4 and 1. Perfect. So y'all over here at -4. Oh, hold on. That second one's, I don't mind that first one, but what about that second one? So that first one is at -4. And then my chat's saying 0. Good job. So since that second one was on the y-axis, it was at 0. So there's 2 of those, so we check that answer. Then it wants the range. What are the y values of these points? So the V point is the smallest y value. And if you look on the y-axis, that smallest point is sitting at
3.
3. There you go. All right, then we're going up. The next 2 points have a y value of 4. And we only have to put the 4 once. Although it's getting repeated in there, we only got to put it 1 time. Now you also going on up the y-axis, I got 2 points sitting at 5. And then finally, on the y-axis, my last 2 points are at 6. Good job. Whoops, let me click back in that box. All right, so you put them in, check that answer. And y'all, the next question is going to be similar to that one, but instead of using dots, they're going to use solid lines on it. So let me make this one larger for us. So remember, the first thing they're asking me for is f of 3. So what y value has an x value of 3? So y'all, we're going to ride down the x-axis until we find 3 here. We're going to go straight up. And let's see what my chat's saying. I'm getting a 3. I'm getting a 3 also, y'all. So good job. All right, so here's the tricky one. What is the domain? Because that domain goes to the right forever. So we say to the right, it's headed towards positive infinity on the x's. But it also goes to the left there. And it's going left towards what we call negative infinity on those x's.
Mm-hmm.
So when those x's go from, say, -infinity to infinity, we say that that domain is all real numbers. So let's see, they got a choice E here. Because y'all, it can't be smaller than something because these lines go on forever. Okay. So remember, when your lines are going both directions like this, it's all real numbers. So you check that. All right, then we hit continue. So what x values is f of x equals 1? So what x values have a y value of 1? Y'all, here's 1 on the y-axis. So I'm just going to go right down that horizontal line. So there's my first point. So what's that x value? That thing looks like 5.
5.
So let me see, my chat's got it. 5 on that one.
Yeah.
And y'all got one more. I think I heard it. This one right here, 7. Good job. So y'all throwing that 5 and 7. So that's the difference on those. When they put a number in with the f of x, like f of 2, they're giving you the x value, you're finding the y. When they say, hey, what x equals, so that f of x equals 1, f of x equals 2, when they're doing that, they're giving you the y values and you're technically looking for the x's. So those two, A and C, are sort of opposite of each other. Now, let me ask y'all this. They want the range. Is this range all real numbers for the y values? Because if you notice, the y values go upwards towards positive infinity, and then below the x-axis, they get more negative towards negative infinity. But y'all, that y value don't come below the x-axis. So it can't be all real numbers because there's no negative y values. So on one like this, what is my smallest y value though? So I'm looking right here at this V point right here. If you're sitting right on that V, which is sitting right on that x-axis, what's that y value? Perfect. I'm seeing some zeros popping up. 0 is the y value. And notice the graph goes upwards in both directions. It's going up. So we say that this one is y such that the y is greater than or equal to 0. Because it does equal 0 being on the line. So y'all, looks like we would pick C on this, is greater than or equal to, and then put in your 0. If you just use the greater than, it won't include the 0, okay? So you got to use the greater than or equal on that. All right, so that's a trick on those little graphs. They're just having you get used to your domain and range. So now let's look at what we say, finding the domain of a function. So we're going to be finding the domain of a function. So when we're looking at a function, when finding the domain of a function, the domain must include all right, y'all, the domain must include all x values that produce a real number when substituted into the function. Now, there's only two things we're worried about on a domain. One we're not going to mess with right now, but it's what we call imaginary numbers. And we'll look at imaginary numbers in the future when we deal with square roots and stuff. But let me ask y'all this. How would y'all get something that is undefined? What makes something undefined? So at this point, we are only worried about whoops, let me write that again. We're only worried at this point with any x values that might create undefined. And y'all, there's only one way that you can get this undefined, and that's if you have something like a fraction and you try to divide by 0. Remember, I cannot divide any number by 0 because that is undefined. So what that means in the long run, y'all, is that we must exclude any numbers from the domain that create a 0 in the bottom of a fraction. So if that'll have if I do got a number that makes the bottom of my fraction 0, my domain will be something like all real numbers except x cannot equal whatever that number is, okay? Now here's the thing. Check this out. For all functions that do not have a variable in the bottom of a fraction, the domain is all real numbers. And the way they say that, they'll have x such that x is a real number. Okay. So that little bar there means such that. And then they tell you what the variable is and any conditions. Okay. This is what we call set builder notation. They give you the variable and then such that x is a real number. If I was kicking out a number, I would say x is a real number and x cannot equal 5 or whatever. Okay. So here's what we do if we do have a fraction. So if we have a fraction as our function, well, if we got a fraction and it's got a variable in that denominator, then we got to figure out if there's any numbers that'll make that equal 0. So what I do, the first thing, I take that denominator and I set it equal to 0. Now, I don't worry about the numerator or the top. All I'm worried about is this denominator or the bottom, because that's what cannot equal 0. You can have a 0 on top of a fraction, but not the bottom. So if you set that denominator equal to 0, then solve for the variable. And y'all, once I solve for that variable, I'm then going to exclude any of those solutions. So exclude any solutions from the domain. Okay. All righty. So here's the thing. If I give us a fraction, then we're going to have to do a little work, find that domain and see what we're sort of kicking out of it. But y'all, if it's not a fraction, there's nothing we got to exclude. So the domain will be X is a real number, okay? So these will start at 3 through 8 or so, I think. So on these examples, find the domain of the function. And you know, like I said, these started at number 3. So my first one is f of x equals 10 over x minus 12. Well, y'all, I've got a variable in bottom of this fraction. So it is possible that there's a number that I can plug into that x and make this equal 0. So since I got a fraction, I'm going to take the bottom of it and I'm going to set the x minus 12 equal to 0. And we're going to solve that for the x. So y'all, looks like to solve this, and we just need to move the 12 to the other side. And we'll do that by adding. So notice I get my x, those cancel. 0 plus 12 gives me a 12. That means if I put a 12 in there, I get 12 minus 12, which is 0. And 10 divided by 0 is undefined. So we got to kick 12 out of the domain. So we're going to kick 12 out of the domain. Right, so to do that, our answer will be x such that x is a real number and x cannot equal. Make sure you pick the one with the cannot equal, and we said 12. But that means any other number you can think of, I can plug into that, subtract 12, get an answer, and then take the 10 and divide by whatever you get. Okay? All right, y'all, question on that?
Not really.
All right, so y'all find the domain of this one. I'll give y'all a p of x equals 2x minus 10. So what's my domain? So let me ask y'all this. Do y'all see a fraction? So
Yeah.
No fractions in this domain. So there's no fractions in this function. So what do we say if we didn't have a fraction? We said our domain was automatically going to be all real numbers. Because y'all, there's any x values you give me, whether it's a decimal, fraction, negative, positive, I can throw any number in for x, multiply by 2, and subtract 10. So since we don't have no fractions to worry about all this undefined stuff, this will be x such that x is a real number. Okay, and that means I can put any number in there on that function and it'll work. So what if I did this? F of x equals, how about an x squared plus 7? Any guesses on that domain?
Well, I think you could. I think it'll be the same thing, the real number, right?
Yeah, because I don't have a fraction. So any number you give me, I can square it, multiply by itself, and add 7. So perfect. So once again, no fractions. So this will be x such that x is a real number. And y'all, that's the thing about the domain. It's got to be numbers that I can put in and I get some kind of answer out of it, okay? All right, y'all, so let me turn the page. Well, they got to give us a few of fractions. So here we go. This one has a 4 over 1 minus 3x. All right, so that's a 4 right there. So I do have a variable sitting in the bottom of this fraction. So this one, we probably going to have to exclude a number out of. Because there might be some number I can multiply in here that when I multiply by 3, makes that a 1. And then that 1 minus 1 makes that a 0. So we're going to take that bottom. We're going to set 1 minus 3x equal to 0. Oh, y'all, so the way I'll solve it, I'm going to subtract 1 and then I'll divide. So I'm going to subtract 1 to move the numbers over. And I get my negative 3x equals that negative 1. And then make sure we divide both sides by negative 3. Because we need that to be a positive x when we're done. So that negative 3 divided by negative 3 cancels out, making that basically a 1x. Now, I cannot divide the 1 by 3, but y'all, these two negatives, remember, when you divide a negative by a negative, you make that a positive. So that's going to end up a positive 1/3. So that means if we put a 1/3 in for the x's, the 3's would cancel, and 1 minus the 1 would make that a 0, which makes it undefined. So we need to kick out this one number. So our variable is x, such that x is a real number. And x cannot equal 1/3. So y'all, if you notice, in this section, all you're worried about are the fractions, it looks like. All right, number 7, p of x. Oh, look, we're going to break out the absolute value. P of x is the absolute value of a x minus 2. So y'all, what are we going to do? We setting anything equal to 0? You excluding anything on that? What would y'all think for my domain?
Since this one is absolute value,
Oh, I
I
see.
think it's a real number, right?
Yeah, there's
Since
no
it's not a
fraction. So
fraction.
Faith got that right too. Faith, all real numbers, perfect, because I can take absolute value of any number you give me and then subtract 2. So since there's nothing making that undefined, good job. That'll be x such that x is a real number. But they're going to throw stuff at you to try to trick you, make you think you got to do something to them. But like I said, in this section, all we're worried about, fractions. So one more of this, and then we'll get into our support. What if I had p of x? Now I'm going to turn the exponents up on this, and this is going to be a x to the third minus 7. So any guesses on the domain? Let's see.
It's a real
Samantha.
number.
Yep, Samantha, you're right, and that's right what y'all just said. It's going to be a real number because I can cube any number, multiply it by itself 3 times, subtract 7, so we're good to go. So x is a real number. And y'all, just wanted y'all to see that on these examples, any function I give you, whether it's an absolute value, whether it's a cube, a square, any of those, they're all going to have the same domain, a real number. What you got to worry about is the fractions, okay? And if you try to get on that calculator and do 4 divided by 0, it's giving you an error message because that's undefined. All right, so now what I wanted to do, since this was a short lesson, I'm going to do the 2.4 support. Bring back some memories from a few things so that when we do 2.4 Thursday, it's not that bad. And it's just going back over what to do with parentheses, adding like terms. And then we even get into a little foiling, okay? So this first one they're giving me a b plus parentheses 4b minus 55. Now, the other day when we had negatives, remember, we distributed them negatives. Well, when they follow a plus, that's just like you're multiplying by a positive 1 through here. So basically, if it follows adding like this, you can drop the parentheses and nothing changes. So we would come down and go b plus the 4b, that's like a 1 times 4, which is still a positive 4b. And then it's like a 1 times a negative 55, which keeps that a negative 55. So if your parentheses follow a addition, the numbers come out with the same sign, okay? So numbers, I'll write that down. Numbers come out of the parentheses So numbers come out of the parentheses with the same sign as inside when following addition. All right, y'all, that can go further though. So what are y'all doing to that? So I got a b plus 4b minus 55. Let's see, Connie, add like terms. And it looks like the only like terms y'all have are the b's. But remember, that's not a 0b, that is a 1b. And y'all also remember this. When you add and subtract like terms, You cannot change the variables at all. You can't change exponents. When you add a b plus a b, you do not get a b squared. You just get b's, okay? So this would be like 1b plus 4b, which would give me 5b. And then I would bring down my minus 55. Now I have no more like terms, so I would be done. So remember, you cannot change the variables when adding, okay? All right, y'all watch this one. 8d minus a 3 minus parentheses 2 minus 5d. So this time, now notice, I cannot add like terms while I got stuff in these parentheses. Okay, so I can't do 8d minus 5d. We cannot do that until we get rid of the parentheses. Now notice, we got a negative here. We're going to treat that like a -1 when we distribute it. So these signs will change this time because they're following subtraction instead of addition. Okay, so the numbers will come out of the parentheses with opposite signs as inside when following subtraction. Okay, so adding, I can just drop them and everything stays the same. So when they're following subtraction, I'm going to distribute. So I'm going to bring down my 8d minus 3. So this is like a negative times a positive, so that's going to make that a -2. And then I got a negative times a negative, that's going to make that a positive 5d. So both these numbers came out of the parentheses with opposite signs as they had in here. All right, y'all, now I'm going to add like terms. So now that parentheses are gone, we can add our like terms. So you got these 8d and then 5d. So that'd be, what's that, 13d. And then you got the -3, -2. And that's what, a -5.
-5.
There you go. And then once again, D's don't add the numbers, so we're done. So y'all, these first two are really getting you used to the parentheses, okay?
Okay.
All right, so let's see what y'all do to this one. -8c minus parentheses -6d plus 6. Close those parentheses and then open after the plus, open parentheses. And I got a 17c minus 8. So notice they threw a lot at us this time. They gave us one following a subtraction, one following addition. So the first step, remember, is to drop all these parentheses. So y'all, I'm going to start out with the -8c. So the question, what's next?
You're gonna do everything, well, work everything in your parentheses, like how we did with the second problem.
I'm going to distribute that little negative. So here you got a negative times a negative. So that's a positive 6d
-6.
minus the 6, because that negative times that positive is a -6. So what's coming next? What are y'all, what's the two next things y'all are putting?
Plus 17c.
Plus my 17c
Minus
minus the 8. Good job. So we changed these ones because they had subtraction again. We left these the same because they followed the adding. Well, I got all kinds of stuff here. It looks like I can add the negative 8c and the 17c.
Right.
That's a 9c.
Yeah.
I've only got the 1d at least, so that's a 6d stays the same. And then looks like my numbers are the -6 and the -8.
-14.
Oh, there you go. So just be careful, okay? Are they following subtraction? Are they following addition?
Mhm.
Now, y'all have heard of the distributed property, right? That's basically what we're doing when we do these. We're distributing. But here, I got a -4 times a 7a plus 10. Now, when you got a negative in front of that number that you're about to distribute, we got to distribute the whole thing. We got to distribute the negative and the 4 through our parentheses. So we got a -4 times 7a.
-28.
Yeah.
Uh-huh.
Yeah.
And then you'll do that -4 times 10. And that'd be what, a negative
-14.
So these were both positive inside, but they did follow some kind of subtraction, so they both became negative. And then we just distribute that 4 through, okay? All right, let's try this one. A 9m times n minus p plus a q. So now we're working on distributed. So if you notice, most of these up here, we're all working distributed property. But y'all, you got a number and a variable. So once again, both of these have to be distributed to everybody. So a 9m times an n is a 9m n.
Mhm.
All right, so y'all keep me going. Distribute that 9m to that negative p. So that's a
-9mp.
negative 9mp. And then distribute that all the way to that q.
Plus 9mq.
All right, y'all. And guess what? You can't go no further because the variables do not match up.
Correct.
Okay.
So they're just bringing you back because we're about to start doing stuff where we FOIL and add like terms on Thursday. So they're just getting you all used to that. So now a little multiplying. 8c squared times 4c. What do y'all get out of that?
Um, would it be? Oh, you know what? I think I know what to do.
All right. So first of all, what's 8 times 4?
32.
32.
So,
All right. So tell me what you get when you multiply c squared times a c.
C cubed.
C cubed.
C cubed. Because remember, since this c don't have an exponent, you always got to treat it like a 1. And when you multiply a c times a c, you're adding those exponents. Okay? So just remember, we're adding exponents when we multiply the variables, okay?
Okay.
All right, y'all, so try this one. 3c times -2c3d3. Now that's one product inside here.
Yeah.
So we're just going to multiply 3c times this and see what we get.
Yeah.
So start with my numbers. 3 times -2.
-6.
C times C3.
C4.
And y'all guess what's going down here at the end? What's left?
Oh,
3CD to
D.
Uh-huh. And see, the D can't change because you didn't have a D here. So I'm going to say a D3, okay? So the exponents are only changing when that variable is being multiplied by itself. It didn't have no effects on the D3, so we just brought that down to the end. All righty, so let me put this one here. I got a 4R plus 5T. 4R minus 5T. Now, these two parentheses look exactly the same other than one's being added and one's being subtracted. So technically, these are what we call conjugate pairs. So conjugate pairs. And something special always happens when I multiply conjugate pairs. Now, y'all, when you have two things in one parenthesis times two things in another parenthesis, do y'all remember something called FOIL?
Yep. First, outer, inner, and last.
Yeah, it's a way to remind you that you got four things you better multiply also, right? So F is the first ones from each parenthesis. So that means 4R times 4R. What's that give us?
16R squared.
Now the O is the outermost. 4R and the negative 5T are the two outermost numbers. So
Negative 20 RT.
Yeah. Mhm.
negative 20 RT.
Mhm.
And I'm going to keep mine in alphabetical order like you just did.
Mhm.
I is the inner two numbers. So that's that 5T times that 4R.
Plus 20
That's 20 RT. 20 TR.
TR.
20 RT.
I'm just going to make it, I'm just putting mine in alphabetical order is all.
Okay. Okay.
Now, check. Now, but if you did keep it a RT here and a TR here, remember, they're like terms, they're just not in the same order, okay?
Okay.
Now, L is for the last ones in each parenthesis, so that's that 5T times that negative 5T.
Mhm.
Minus 25 T squared.
That- mhm.
Perfect. All right, now, since these are conjugate pairs,
Mhm.
something's going to happen to these two middle terms here.
They cancel each other out.
They cancel out, y'all, because you got a negative 20, positive 20. Those cancel. So my final answer will be the 16R squared
Minus 25
minus the 25
T squared.
squared. And I'll tell you something else about these. When you FOIL conjugate pairs like these, this answer is what we call the difference of perfect squares. Right? Because 16 has a square root of 4, 25 has a square root of 5.
Mhm.
So conjugate pairs will always have two terms that are what we call perfect squares in them, okay? All right, so that's bringing back memories, right? What was that, number 8? So let me turn this paper here. All right, y'all, so 9. So I will say the rest of these are just working on foiling, okay? So this number 9 has a R minus F times R minus F. Now, although they're the same, these are not conjugate pairs because they're both being subtracted. So that means our middles aren't going to cancel on this one, okay?
Okay.
So let's foil this and see what happens. So F, R times R.
RF.
Oh, I'm doing the R times R.
Oh, R squared.
R
Squared.
squared
Uh-huh. Now the R times the negative F.
Negative
Okay.
RF.
minus RF.
Okay, I'll just keep it in the order y'all are giving me. Now, right here, you got a negative F times the R.
Negative FR or RF.
Realize those are like terms, though, RFs and
Yeah.
FRs, okay?
Yeah.
And then how about that negative F times that negative F?
F squared.
Plus
That's
F
F
squared.
squared.
Uh-huh. So guess what? You do have like terms here in the middle.
Mm-hmm.
They don't cancel because they're both negative. So we're going to bring down that R squared in the front. So that's what, a negative 1 RF and a negative 1. So negative 1 and negative 1 give me a negative 2 RF. Or you could do FR.
Yeah.
Math Lab should take it either way. And then at the end,
F squared.
F squared, okay? So just remember, the conjugates canceled, but when they're both the same sign, they do not cancel. All right, so now I think this next one just having fun with the exponents. X3 plus 7 times X3 minus 5. All right, y'all, so let's see what y'all get when you do an X cubed times an X cubed.
X to the 6th power.
All right, then that X cubed times that negative 5. So that's what, a negative 5 X cubed. So you see what FOIL has you do?
Yeah.
You're basically distributing the first term to both of these, and then you're distributing the second one to both of these. So here you got 7 times X cubed. So that's a positive 7.
Then X cubed.
Uh-huh. And then finally that 7 times that negative 5.
Minus 35.
So can this one go further?
Yeah.
Because we do have like terms sitting
Yeah.
right here in the
Yeah.
middle, don't we? So I'm going to bring down that X6. So I got negative 5X cubed plus a 7X cubed.
2X cubed.
So there's my 2X cubed. And then let's see, at the end we got our
minus 35.
minus 35. Okay.
Mm-hmm.
All right, y'all, one more. And that'll be the support that'll get us ready for Thursday. Now this one's throwing the alphabet at us too. So my first parentheses, C squared minus 4T squared times C squared minus 3T squared. All right, y'all. So you're going to take this C squared times a C squared.
C to the 4th.
Fourth.
C squared times a negative 3T squared.
Okay. Minus 3C squared T squared.
Perfect. Perfect. Good job. They get a little tricky when they throw all these variables at you. All right, y'all. Negative 4T squared times my C squared.
That's negative 4T squared C squared.
And just remember, these are like terms. It's just my C's and T's are out of order.
Yeah.
All right, so what's left? The negative 4T squared times the negative 3T squared.
Plus 12T
L.
T
to the 4th.
to the 4th. There you go. All right, y'all. So just remember, T's times T's, 2 plus 2 gave me 4. Over here to C times C, 2 plus 2 gave me 4. All right, we do have like terms in the middle.
Yeah.
And that's why a lot of times when people do these, they keep them in alphabetical order so they can tell. But just remember, you got C's and T's, and both of them have exponents of 2's on them, okay?
Yeah. Yeah.
So you're going to bring down that C4.
Mm-hmm.
All right, y'all, you got -3 of these and a -4 of those.
Right. So -7.
Uh-huh. And C squared,
squared.
T squared. And then at the end, where's my, oh, my
12 T4.
12 T.
T4.
Okay. So I guess if that's giving you any clues, we're probably going to be doing a little foiling Thursday, right?
Yeah.
Yeah.
But it's not that bad. Just remember stuff like when you're multiplying, you're adding exponents on the variables. When you're distributing, we distribute negatives like a -1 through parentheses and positives, just like multiplying by a +1, which ain't changing nothing, okay? So this right here will get us ready for Thursday. So tonight for 2-3, really, all that's due for 2-3 was the college algebra doing the domain problems. All right, y'all. So any questions? So we got a short night tonight, basically, because that one section in college algebra is pretty small. So does anyone need any help on anything?
No, I think I'm pretty good.
No, sir.
Yeah, we start sort of mellow in here, so it'll get picking up before long. But right now we're sort of in the stages where most of this is sort of like a review on y'all and stuff. So now next week it gets a little challenging, some of them. So it looks like nobody's got any issues. So I'm going to stop this recording so I can send it out in a little bit.
Okay, great.